Hey, and welcome to this last episode in the series about platform engineering at DASA. We're very sorry about the hiccup today with the live stream, so I thought I'll start and go ahead and record the session for you folks to rewatch it. So thanks for your patience, thanks for your continuous interest, and I'll make sure to make this as entertaining as humanly possible. But let's get cracking. So, this is me. I'm Markus Eisele. You can reach out to me whenever you want. Like, literally, I have an email address that is working. I am available on Blue Sky. You can reach out to me on Mastodon and on this other side. And if you stay patient or scroll to the very end of this presentation, you get a couple of free download links for my books. And also, I have a new book announcement coming up. So stay curious if you want to learn more. I am a developer turned sales turned marketing, and I'm now sharing my passion about all the relevant topics around developer productivity and stuff that moves me on a daily basis because I do still love Java and love programming in Java. So that's the reason why I'm continuing to talk about all these topics, and I'm trying to get all of you excited about all of this. Before I start, I was wondering if you all know what Red Hat actually is. The company I work for is the world's leading provider of open source enterprise IT solutions. We're a fully owned subsidiary of IBM. 20,000 employees, roughly ballpark number. What is even more important and not on this slide explicitly is that we're all about open source. Everything I'm going to talk about today, and even the product logos you might identify, they all are backed by open source and available as open source. So basically, all it needs to go there, download, try it out, is register on developers.redhat.com, get your developer account for free, start working with what you see, what you like, whatever I'm talking about today. Make sure to just check in with us. So, why is a developer talking about platform engineering in general? And what's the fuss about it? Like, it seemed to come out of nowhere as like a new topic. And I think this is something that I wanted to address very front up to make to level set the stage a little bit. Why is platform engineering important? And I was looking for a way to convey this message, and I kind of wanted to also weave in how old I am because I do feel old, even if I'm running quite a bit and trying to be as healthy and fit as I can be. As a matter of fact, when I started in IT, that was around like 1996, 1998, I believe. That was still Perl and like Common Gateway Interface programming, the first websites, HTML. My experience go way back to Java 1.0. But if you compare these like early times in our industry to the accelerated pace of new technologies, new projects, it's almost exponential. And the speed is, there's no sign it's going to slow down at all. As a matter of fact, I expect it to even continue to pick up and continue at that light speed that we're seeing right now. If we just look at what the Cloud Native Foundation offers in terms of projects and technical solutions, that is just mind blowing how fast they went from literally the first CNCF project all the way to I have to sneak 138 plus projects as we speak today. And looking at what the new AI era is bringing, this is definitely doomed to grow even more. And this is a good thing, technically, because it means choice. It means we can make the right choices for the requirements we have at hand as developers, as software architects. But on the other hand, oh, this is exactly the reason why some software systems become complex because the number of potential combinations of technologies is growing exponentially. And this can lead to all kinds of negative side effects. And these impacts of complexity that is inherent in not only technology choices, but also infrastructure, configuration, and last but not least, the programming languages of choice. It doesn't all have to be Java, even if I would like it to be. This all literally comes down to a lot more than just complexity. It is exactly the reason why the developer productivity is continuing to slow down, because we have so many choices, we have so complex environments. Just think about microservices, distributed systems, automatic scaling, environments that need to be provisioned. And on the tail end of software development is always maintenance. That equally gets more complex if we want to touch these existing systems, if we want to continue to keep them up to date, maybe even work on some technical depth. And on the business side, this definitely leads to less output, less value generation from a software developer. I think I remember I've seen some statistics just lately, like 38% of what developers do at least has nothing to do with software development. It's mostly configuration, making sure every piece fits to the other pieces and everything continues to work. And there's also this like nasty security piece and implication in all of this, because with choice and accelerated pace, you also incur a lot more potential vulnerabilities. In the Java ecosystem, we absolutely love remembering Log4j and what happened to this famous logging library that literally was used all over the place. And that wasn't even a bad choice to make from a technology perspective, but it had to be mitigated. And just think about this multiplied by times X when you have more technology choices you're making. And this basically, all of this is reflected in a couple of surveys that you can see. And if I talk to customers, their biggest challenges continue to be application modernization. How do I move my heritage, my legacy software into a modern world? How can I increase the power of my developers? How can I make them happy? How can I make them more productive? So I get back to a lot more value stream focused software development. How can I integrate this new world of AI, if it's generative or predictive or whatever, that's also gonna throw a lot of new requirements at software developers. And lastly, software supply chain management. How can I, as like a business owner, make sure the software that's being developed is safe and sound, and nothing gets into the way and gives me an opportunity to identify vulnerabilities early and often. So it all comes down to mitigating complexity. And there's basically two levers that you can pull. There's the left side, which we all know and hate for a living, in particularly as developers, which is all reference architectures, blueprints, master solutions. We all feel like that's a description of roadblocks. Literally, you cannot make choices. Technology choices are deliberately kept small. And maybe they don't even consider the correct solutions for the requirements at hand. That ultimately also slows us down, not only us as developers, but complete teams in the worst case. And on the other side, this is what I like to call anarchy, right? Like everybody gets to pick and choose. We're the happiest campers using whatever technology is out there in small pizza sized teams. We're just using whatever we need from any vendor and we're building it out in an agile fashion. This, as we've learned, can be heavily risky. So, how do we mitigate this? How do we still do more with less of? So, generate more revenue from what we're building, like software, value, production? How can we make it more secure? How can we make sure it's more resilient, and so on? Like, with less cost, less risk, less time, maybe even less tickets, and absolutely less stress, because that's bad for your blood pressure, right? And ultimately, this is where platform engineering comes in. It is built as the thing in the middle that balances all the requirements between going too slow and becoming too risky on your path. And Gartner classifies platform engineering with five main characteristics: self service for developers, a fully automated environment, secure and consistent, whatever that means. We're going to look at that. Developer experience, obviously, that's one of the more important pieces here, and continuous improvement, which is also super, super important. Think platform as a product, but I'll scratch that a little bit later on. What I want you to remember is that the platform engineering we're talking about here is not about building a piece of infrastructure. It is about building a foundation that makes value delivery easy and ideally fun. So don't think about it as like the container platform of choice that you were buying with the best features. Think about it as the ideal software delivery piece that helps you and your teams be absolutely agile and fast as you would like to be, without roadblocks at all, in a total self-service fashion. Well, this sounds very marketingy, and I agree to a certain extent, but obviously, if we think about what developer struggles are when embarking on a new project, when doing some software development, these are some examples. Like, where do I put my documentation? How do I get my code deployed, and where, ideally? How do I give get feedback about my application? Is it working? Is there a process in place? What's the preferred tooling to use? And all these questions get asked over and over again. And you basically have to get up to speed with all these nitty gritty pieces when you want to be productive in a new project, right? So I think about platform engineering basically as optimizing the flow of value, which basically comes down to the speed that it takes from an idea to all the way into production. It's a modern development workflow basically that we're trying to create with the help of a software development methodology. Meh. Platform engineering is way more than just infrastructure. It's a little bit of methodology, it's a little bit of team structures, it's a little bit of tooling, and definitely it's a concept that embarks on a journey that strives for continuous improvement, delivering the ideal developer journey for all of us without any roadblocks at all. And if you want to sell this to an operations guy and really want to understand, hey, how is all of this governance coming together in platform engineering when it's just developers talking to platform engineers? This is when I usually pull up this slide, and it basically shows how the platform engineering team is in the middle, taking requirements and product ideas from not only the developers who strive for the most perfect working environment and their favorite IDEs, but also from operations, where we have all the governance requirements that need to be fulfilled. So platform engineering is taking the requirements from both worlds and putting them into something that looks like guardrails. And maybe we can talk about this a little bit later on, but the bottom line is, if you empower developers, if developers are happy, they are more productive, and they are absolutely in a space where they want to be, sitting in their basement just writing code without having to worry about thousands of lines of YAML. And even if that's spoken for me personally and my favorite, I know that a lot of people think alike. We don't really want to configure infrastructures. Ultimately, we just want to code. And happy developers just code more and more professionally. What could be some measurable metrics or KPIs that you could use to define the success of the platform you're building? Well, it heavily depends. Obviously, on your requirements, on your settings, on what you want to achieve, maybe even in what kind of industry you're in, if it's heavily regulated or if it's like more modern, up to date, a little bit less requirements coming from any kind of laws or whatever. So I wanted to give you an idea about success metrics that you could potentially think about. And if you don't read the full slide, that's totally okay. I promise I'm not going to read it to you. What is important is to look at the big buckets. So it could actually be some metrics out of the bucket of operational performance. So how long does it take to recover from a failure in production? That is a perfect DORA metric, like we all know. But it could also be a platform success criteria. So monitoring it over time, if it improves or not, that might be a good indicator. Another reason or another bucket could be workload adoption. So how many of my applications are actually interested in the services my platform offers? Am I good enough? Am I attractive enough from a platform perspective? That could definitely be a good KPI, but also some team KPIs or collaboration improvements, the number of documentation that is available through the platform, whatever. So I said I'm not going to read it, so I won't. Just take some inspiration from this if you're looking for it. What is important to me personally is that you do absolutely remember that platform engineering is not only a methodology, not only a technology, it's a way of shifting software delivery from the traditional, almost waterfall, completely automated, very project specific approach, all the way to almost a centered, around platform centered, continuous improvement approach, bringing software into production. And I'm stressing this continuous improvement, and I'm trying to very vaguely express what I think a platform should deliver in terms of services, because it should be optimized for your requirements. So there is no one size fit all. And guess what? There's also not the one product you can buy. So you cannot buy platform engineering, and you should not. You should build your own best practices around it. I absolutely recognize that I won't get away without showing you at least a couple of somewhat high level examples. And when I say high level, I actually mean I'm not going to talk about them in depth, but they are a little bit more concrete. This is a very simple example where we technically just use the central portal, in this case, the Red Hat Developer Hub based on Backstage, that exposes developer centered and development team centered functionality through their plugins to the team. So you can literally scaffold existing projects from the software templates mechanisms in Backstage. And they could kick off the complete provisioning and provide all the templates and pipelines necessary for downstream technologies. Think about Argo CD or Tecton pipelines. And all this could absolutely also use existing infrastructure components. You could pick and choose from deployment groups, databases, whatever's necessary. And all this could be specified for a specific component type in your organization. Is that component type technically cut? We're thinking microservice, or it could even be a business cut. Let's say an underwriting service. Oh, wait, that was a big cut in terms of insurance terminology. But anyway, you get the message, right? It is basically, I like to call it an autobahn because these software templates function as a mean of capturing best practices and established governance principles. And we as developers, we just say what we basically want to build upon if it's a service of a specific kind. And we just get kickstarted with the organization's best practices. Another high level example could be a secure software supply chain, where we basically not only use the software templates as they are to scaffold individual bits and pieces for our code or infrastructure, but it could also be that we use pipeline tasks to sign and verify these results, starting with like an individual Git commit that gets signed and all the downstream binaries that get created throughout the software pipeline basically also get validated and maybe even according to enterprise contracts. All this can be part of a platform for developers adhering to platform engineering principles. So take this as a little bit of an inspiration. And if this isn't enough to tease you, this is a screenshot from the Red Hat Developer Hub. It's a little bit skinned. What you see here basically is one component that got scaffolded through the software template mechanisms in Backstage. And think about it, looking into the future, this could technically also scaffold complete AI inference infrastructures. If you're extending your developer platform with generative AI, you can capture the available and blessed models in your software templates. So people can choose from like Granite or anything else that your company uses and do actually get a raw skeleton of software that they could use for, think LangChain 4j or Quarkus even as a JVM library. And all this can be encapsulated. And in case you're super curious and want to play around with this, like instantly, because it hit a nerve right there, I did put a couple of like 8-point links at the very bottom of some of the slides. So you can check them out like as soon as you get your hands on the presentation that I hope will be delivered to you at some point and not only the recording. But yeah, these software templates are basically large YAML files that get imported. And that is literally just an import and can be made available. We've talked a little bit about the platform and how could that look like if you cannot buy it. How should you start building it? I did tease the portal aspect a little bit, but developers usually work in their IDEs anyway and use Git as like their interface to trigger builds. So what kind of attributes or layers does a platform actually need? And that is a really good question. This is a particular Red view of the world. If you are familiar with Red Hat and our tooling, this is an adopted version of our technology stack, which basically expresses how the software supply chain and developer experience sits on top of everything that your Kubernetes environment already presents. So think about cluster management and security, the underlying Linux infrastructure. Maybe you are lucky enough to already use OpenShift as your Kubernetes environment, or even more in the best case, ideally. Then you can just think about it like this. If you're thinking about it from a requirements perspective, you could potentially come up with another layered approach that also starts at the environments on the very button and goes all the way up to developer experience. And I did sprinkle some technologies and open source projects into this. Obviously, you need monitoring and logging. You need to think how you want to do continuous integration and delivery. Is that going to be Tecton pipelines in Argo in a cloud native world? Do you want to use Jenkins as a more traditional approach? How do you want to do microservices? Do you want to work with a service mesh approach? And how's your build working in this all complex scenario? So depending on how you want to look at it, this cut and the requirement buckets are actually loaned from the platformengineering.org group. These folks did create a couple of reference architectures that I like very much. They are comparably self-explanatory and give you a good overview for like the first buckets. Think about it, MVP kind of style for your platform. I've teased Developer Hub a little bit. Let me showcase what Backstage or Developer Hub actually do cover in such a scenario. And I want to clean up a little bit of an acronym hiccup that happens quite a bit in the platform engineering world. We do talk about something that is called an IDP. And the ID usually stands for integrated developer, and the P can have two meanings. One is portal for like the front end pieces, and the other one is platform. So depending on whom you're talking to, you will see two different interpretations of this. I technically want to focus on the portal piece here, meaning the front end that actually makes our lives as developers a lot easier. And if we're just looking at this front end piece, I think the really interesting aspect here is that it is becoming the single pane of glass for us as developers. Instead of having to open 20,000 bookmarks in Google Chrome or your favorite browser, you will have your ideal work environment that exposes everything you need, including all access to all the downstream systems, pipeline, infrastructure, security, monitoring, you name it, in a reasonable, standardized way. That makes it so much easier. And ideally, it also comes with some kind of visibility control. It's somehow called RBAC for a reason, but ultimately you don't want to see all the 20,000 projects that are in Red Hat Developer Hub at any given time. You only want to focus on the projects you are actually interested in because you're assigned to them as like a team member. This is your gateway to self-service. Instead of having to open tickets, if you need a new environment, you basically use the functionality exposed through the Red Hat Developer Hub. And this is kind of the beauty of the integrated developer portal. It gives you everything you need at your fingertips. And this all starts with the software catalog, which basically lets you not only find components, but also complete software systems. So there's interdependencies that are modeled in this catalog. And that gives you the ability to not only search for them, but also understand how they interconnect. That is becoming increasingly more important if you're thinking about distributed applications, microservices, whatever. Because it is becoming challenging to navigate them, in particularly in very large scale environments. The other thing is standardized documentation. It's called Tech Docs in Backstage, and it basically attaches to the individual software component that exposes everything necessary all the way down to APIs that are being exposed and consumable through a standardized way. So no matter what application you're onboarding, you will always find your documentation for software components in the right place. And all this obviously only makes sense if the portal is customized to all your downstream systems. I've mentioned Tecton, Argo, Jenkins, whatever systems you're using. You will find a specific plugin that enriches the backstage portal in a meaningful way, so you can basically build it out the way you need it for your specific platform. Is there anything that comes out of the box? There is a ton of functionality that comes out of the box, but all this is starting to be very worthy and worthwhile for development teams the more it gets customized and optimized towards the actual necessities. So you can like strip up everything that is not needed, which is basically the big plus of the single pane of glass. And if you've done all of this, you basically are in the wonderful situation that you can feel the developer joy again. And this is basically what motivates me to speak about platform engineering and also make sure you folks get an opportunity to build out what is making your developers happy and making them more productive. I talked about a little teaser. We are writing a new book. Yes, yes, we do have a day job, so the book writing goes aside. But we still wanna share what we've learned, and in particularly the many years of experience me and my co-workers have with enterprise Java development. Do absolutely need a little bit of an extension towards AI. We wanted to share what we've learned about this new world and give you an opportunity to also profit from this. Learn how you integrate artificial intelligence, and that might not only be generative, that might also be predictive or other kinds of AI systems, neural language processing, deep learning networks. Learn all about the basics. This is available for free as a preview version as it stands, like early release. Not a lot edited so far, but you can just go either to O'Reilly if you have a learning subscription, or visit the developers.redhat.com website and grab it from there, because there's also the PDF download already available. If you want to learn a little bit more about what enterprises think about platform engineering, we did team up with Illuminas and ran a survey. And if I'm not completely mistaken, this is one of the larger ones in the industry. So find out what thousands of IT decision makers and platform engineers gave us as feedback to our questions around platform engineerings and what the biggest findings are. Just use this QR code if you're interested. And as I already mentioned earlier, don't forget to register for developers.redhat.com. Your free place for all kinds of digital swag, O'Reilly ebooks, custom made cheat sheets, or even learning path if you want to brush up your knowledge around Kubernetes and latest technologies. Thank you so much for listening. If you liked what you hear today, you are more than welcome to check out all my resources on the web. And I also want to mention that DASA is running a platform engineering certification. So check out their website to be up to date on their latest offerings. It was a pleasure to be here today, and thank you all for listening and spending your time with me. I hope to see you soon somewhere. Stay healthy. Bye.